Hello students, in this video I am going to cover preparation of alkyl halide. Now here preparation of alkyl halides means whatever you want, your product will be at right side. So this is the preparation of alkyl halide. Okay. And from that molecule from which you have to prepare alkyl halide should be at left side. This is a simple method. Now, first method is chlorination of alkane. Now, you know R is alkyl group and hydrogen is attached, means it's a alkane. Alkane on chlorination. It's a substitution reaction. In presence of diffuse sunlight or UV light, this Cl replaces hydrogen atom to form RCl plus HCl. Now, this is substitution reaction. Means, what is substitution reaction? An atom or group of atom which replaces an atom or group of atom is called as substitution reaction. Here, Cl replaces hydrogen atom and the product is RCl plus HCl. Now, the criteria for this is the reaction should be under diffuse sunlight or UV light. Now, example, this is methane plus Cl2. In presence of diffuse sunlight or UV light, this Cl replaces hydrogen atom so to form CH3Cl plus HCl. Now, this is methyl chloride is from or chloromethane is formed. This way, alkyl halide means methyl chloride is prepared. Second example, ethane on chlorination in presence of diffuse sunlight or UV light. The Cl will replace its hydrogen atom to form C2H5Cl plus HCl. It is and the product name is ethyl chloride or chloroethane. So this is very simple reaction of chlorination of alkane forms alkyl halide. Question can be asked, write down to preparation of alkyl halide, or how will you prepare methyl chloride? How will you prepare ethyl chloride by reacting Cl2 gas? This type of question, if asked, then you have to write the explanation and then reaction. Okay. Next, same type of reaction, bromination, also shown. This is alkane. Alkane on bromination in presence of anhydrous aluminum bromide. This Br replaces hydrogen atom to form alkyl bromide and HBr. Now, this is again substitution reaction. Why? Br replaces hydrogen atom to form a product. Substitution reaction takes place. You have to remember the type of reaction. Now, see the example CH3H, CH3 and H means it's a methane plus Br2 in presence of anhydrous LBr3. This Br replaces hydrogen atom to form CH3Br plus HBr. Second example, C2H5H means it's a ethane plus Br2 in presence of anhydrous LBr3, aluminum bromide. Br replaces hydrogen atom and therefore it's a substitution reaction and forms bromoethane plus HBr. Now, second type of reaction. First was substitution reaction. Now, I am going to tell you about addition reaction. What is addition reaction? Addition reaction takes place across the double bond and adds two molecules to form only one compound. That is addition reaction. So here, two reactants are there and forms only one product. This is called as addition reaction. Only one product, no byproduct will be formed, and this is called as addition reaction. Now see, this is general reaction. This is alkene. The two carbon atoms are attached with double bond. It's unsaturated compound plus hydrogen halide. You can take any hydrogen halide. Now what will happen? This is pi bond. Okay. So it's a loosely bound electron and hence this bond breaks and two valencies are opened. That two valencies are satisfied by hydrogen 1 on one carbon atom and X on second carbon atom. So this hydrogen and halogen adds across the double bond. This is called as addition reaction and alkyl halide is formed. No byproduct is formed in this reaction. So ethene, example, plus HBr, okay, eh, it will form ethyl bromide. Now, this alkene was symmetrical alkene. Symmetrical alkene adds across adds to the HBr to form ethyl bromide. There is no problem of joining hydrogen and bromine on carbon atom. But if the alkene is asymmetrical, asymmetrical means number of carbon atom around the double bond are not equal. That is asymmetrical alkene. For that, Markovnikov's rule should be applied. When an unsymmetrical alkene reacts with unsymmetrical reagent, then the negative part goes to that carbon atom of double bond having less number of hydrogen atom. Now we are going to see this reaction. This is unsymmetrical alkene. This is double bond. Here two carbon atoms are there and on right side only one carbon atom. So it's unsymmetrical alkene plus HBr. Now open the double bond. The negative part will go to that carbon atom of double bond having less number of hydrogen atom. This is the Markovnikov's rule, and if Markovnikov's rule followed, then the product will be 2-bromopropane. Okay. Now reverse to this Markovnikov's rule. That is the peroxide effect or crash effect. Unsymmetrical alkene on treatment with unsymmetrical reagent in presence of peroxide right now. What will happen? The negative part of the reagent goes to that carbon atom of double bond having more number of hydrogen atom. Okay. So here open the double bond. The Br will go to CH2. The hydrogen will go to CH and it will form 1-bromopropane. So in Markovnikov's rule, 2-bromopropane is formed and in peroxide effect, 1-bromopropane is formed. Means here secondary alkyl halide is formed and here primary alkyl halide is formed. So Markovnikov's rule gives product of secondary alkyl halide and peroxide effect gives product like primary alkyl halide. Okay. So this is about the preparation of alkyl halide. One reaction was substitution reaction and one reaction was addition reaction. Thank you.